I'm Rajyalakshmi from CIET. Today I'm going to share a topic asymptotic notations. The asymptotic notations are based on a time complexities. So the time complexity will not depend on a number of inputs. For example, searching for a specific item in an array of n elements using linear search, we have to follow the three situations. So like a best case, average case, and a worst case. So in a best case, it is a maximum number of steps that can be executed for a given parameter, and the average case is it is an average number of steps executed for an given number of parameters. And in worst case, it is the maximum number of steps that can be executed for a given parameters. So in these the three cases are according to time complexity. So in asymptotic notations also we have three complexities. So that is big O notations, big omega notations, and big theta notation. In big O notations, the time complexity is not increasing faster than f of n. So it is calculated for upper bound of the complexity. And in big omega notations, the time complexity is not increasing slower than f of n. So it is calculated for a lower bound of complexity. And theta notation is usually used for average time complexity. So the complexity is equally increasing to f of n. The asymptotic means a study of a function of parameters n, and n becomes the larger and larger without a bound. So f of n is the larger bound of the time complexity. So concerned about how running time of an algorithm increases with the size of inputs. So asymptotic notations is other method for finding a time complexity for an algorithm. There are different kinds of mathematical notations for time complexities. So basic efficiency is the number of times a statement is executed is usually referred as frequency count. So we take the frequency count of each operation to calculate the time complexity. So among all frequency count, we will take the maximum frequency count of any operations, which will be the order of an algorithm. So the time complexity of a linear search is worst case is order of n, and the time complexity of linear search in best case is order of 1. So this is an example for big O notation. So the basic function f of n is equal to 3 log n plus 100. So g of n is a log n, is f of n is the function is f of n is less than or equal to order of g of n. We have to prove the function f of n is less than or equal to g of n. So 3 log n plus 100 is less than or equal to c into log n. So hence it is proved the definition of a big O has been met. F of n is order of g of n. Theta notation. So the theta notation is given the function f of n and a g of n. We say that f of n is equal to theta g of n. It is if there is a positive constant c1 and c2, and for all positive integers, n naught, such that c1 g of n is less than or equal to f of n and less than or equal to c2 g of n. For all positive integers, n is greater than or equal to n naught. So a function f of n belongs to set theta g of n if there exists a positive constant c1 and c2, such that it can be sandwich become between a c1 g of n and c2 g of n for a large number of large value of n. So it is calculated for a average time complexity. So theta notation is used for the average time complexity between a c1 g of n and c2 g of n. So omega notation, the given function f of n and g of n, we say that for f of n is equals to omega of g of n if there exist positive constants c and n naught. So we have to prove cg of n is less than or equal to f of n for all non-negative numbers n greater than n naught. So big omega notation is used for it gives lower bound of the time complexity. This is the example for omega notation. So we have comparisons in asymptotic notations are order of 1 is used for constant statements. So like assignment statements are all constant statements. So the frequency count will be 1 for all constant statements or assignment statements. So order of 1 is the time complexity for constant statements. So logarithmic statements like divide and conquer methods are used in the logarithmic expressions. So order of log to n is used for a logarithmic expressions. And linear expressions, linear expressions means looping statements. So that is looping statements in order one loop, one for one loop statements order of n. And quadratic statements and cubic statements are minimum of 2 to 3 for loops are used in quadratic and cubic statements. And exponential statements order of 2 power n. So factorial statements are like a factors calculating factorial of n numbers. So that functions we are using order of n factorial asymptotic notations. So this is an example for asymptotic analysis, like the number of iterations, the number of iterations, the runtime of the statement inside the loop. For example, for int I is equals to 0, I less than n, I plus plus. So it will be increment up to n plus 1 times. So constant is a c, total time is a c into n. So for loop calculates n times. For loop iteration is becomes for n times. So the time complexity of the for loop is order of n. The outer loop executed n times and the inner loop executed n plus 1 times. So two for loops are executing at the same time. So c into constant c into n into n, so n square, order of n square is the time complexity for two for loops. One is the outer for loop and the second one is a inner for loop. And add the time complexity of each statement. So executes for loop executes n times and outer loop executes n times and inner loop executes n times. So here we are using a three for loops at a time. So c into n, c1 into n is the for constant c1 constant time for c1 into n. And second for loop is one is outer loop and it has inner loop also. So c2 into n into n, n square. So the total time complexity is order of n square. So the maximum number of complexity where we can get power notation, that is the time complexity for looping statements. So here we have a if condition. So if condition executes n times. So if length is greater than or greater than 0 for an int I is equals to 0 to n I plus plus. So here if the condition is true, then only we can go for a for loop, so that the entire loop executes n times. Okay, so m is equals to m plus 1, constant time is c1. So else else for I is equals to 0, I less than n, I plus plus, if I greater than 0, k is equals to k plus 2. So here we can get a second constant time c2, and else inner loop is for I is for int j is equals to 0, j less than n, j plus plus. So the third constant time is c3. So here we are using two for loops. Entirely we are using two for loops only. One is under if condition, and another one is under else condition. So we are totally using only two for loops. So n into n. So first for loop executes n time, and else in else conditions also for loop executes one time. So n into n into c3. So the total time complexity is order of n square. And we have also little omega notation. That notation is used to provide a lower bound, which is not asymptotically tight. Big omega notation provide a strict lower bound, and a little omega notation provides a lower bound, asymptotically not asymptotically tight bound. And little omega notation means that f of n can be never lesser than the g of n. So thank you.